Hi folks, today we're going to be talking about the logic converter. Logic converter is a pretty powerful tool in multisim. It's going to allow us to take any sort of logical statement, truth table, anything like that that we might have, and convert it into convert a truth table into a logic statement into a circuit, a logic statement, truth table into a NAND only circuit, or a few other options that we have in there. It's basically going to take a truth table and create a circuit for you. So this is a tool that you can't use until you get to this assignment, because I need to make sure you know how to use truth tables, and I need to make sure you know how to use a truth table, turn that truth table into a logic expression, and logic expression to circuit. So doing this is going to save you a lot of time, but you have to do me the favor of waiting until you complete those first assignments up until 1.2 or 2.2.4 in order to use the logic converter. Because the logic converter takes out a lot of the work, but it also takes out a lot of the learning, right? So you can only use the logic converter once you've mastered truth tables, logic expressions, and logic expression to circuit. So in Multisim, in order to get at your logic converter, it's just over on the right side here. You're just going to click on it once, and you're going to come and bring it out. It looks just like a component, but it's not a component. It's a logic converter. It's going to transform one thing into another. Right? It's going to convert a logic statement into a circuit for you, which is pretty awesome. So in order to do that, the first thing that I'm going to do is I'm just going to be looking at this assignment here. This is the 2.2.4 logic tool assignment, right? And we're just going to be using that PVST majority voting machine project that we used earlier in the year, right? So that should be a hint to you that if you're looking at this video before you've done that, you got to make sure you show me all of your work. All of your design work has to be present with any of those major demonstrations. All right, so there's our truth table that we're going to use. We're going to need our truth table handy whenever we're using the logic converter, because we need to enter a truth table to start. I'll just click on this, and it opens up my logic converter. Now, right now, the logic converter does nothing for us because it has no inputs. I'm just going to go along in there, and the voting machine has 4 inputs, PVST, in this case represented by ABCD. You'll see it creates a truth table for us there with untitled outputs, right? They could be a 1, they could be a 0. We have to tell them which each one's going to be. I'm just going to go through and I'm going to make that match the voting machine here. By clicking on it once, I turn it into a 0. Looks like the first 2, 4, 6, 7 of those are zeros. So I'm going to make those zeros. And then we've got a 1, a 0. So we'll click twice to get a 1. Then we've got a 0 and a bunch more 1s. You can see my version of Multisim is struggling to record when I'm recording a video as well. That little bit of flickering shouldn't happen for you. It's kind of lagging out a little, but that's how it goes. Now, we can convert this into a logic expression by just clicking this truth table to logic expression button. Now that creates the unsimplified logic expression. What you'll note is down here, where there's all the logic expression is written out, instead of having a line above a letter, it has like an apostrophe after it. What that does, that apostrophe tells us that that's D naught or A naught or C naught, right? The apostrophe goes with the letter that comes before it. So in the instance of this very initial one here, this A with the apostrophe over it is A naught. Now, this is the unsimplified version of our logic expression. We could use this and we could create a circuit using this button down here. But that's going to be our least simplified circuit. So what I'm going to do, I'm going to click Simplify. That's going to shrink that logic expression right down a ton. What we're going to see is that our expression is now BCD or AB or AC or AD. This is PVS, or PVS, or sorry, excuse me, long day. This is either VST or PT or PS or PV, right? This is our president and the vice, president and the secretary, president and the treasurer, or the treasurer, the vice president, and the secretary all voting. This now has our simplified logic expression. This should be familiar to us from before. Now what we can do is, instead of creating a giant circuit and wiring it by hand, we can just click the AB button. AB into logic button and click it down on our page. Now what this has done for us, this has created our circuit. You'll notice our circuit has no inputs, so we'll have to go in and we'll have to wire in our switches and our output. However, this took out all the design work of going in and picking it out. It's kind of handy for us. One last thing I'd like to show you with the logic converter is that if I had just gone in and I had just typed in from the start without filling in a truth table, so let me actually go, I'll delete this, get a new one. You don't need to do that all the time. I just want to show you it with something blank. If I just came in here and I had typed BCD or AB or AC or AD, right? That's our truth table. And I just clicked our logic expression, A, B, etc., to circuit, it would create a circuit for me. But if I click that and I convert it into a truth table, it would just bring up a whole truth table for me. We can convert a logic expression to a truth table, a logic expression to a circuit, a truth table to a circuit, a truth table to a truth table to a simplified logic expression, etc. The last thing we can do with this, we can take a logic expression and we can convert it to NAND-only logic. If you haven't gotten a NAND-only logic uses only NAND gates to build everything. So I'm just going to click that button, and it's going to create the NAND-only version of that circuit. You can just drag that down here. You can see it's a little bit longer. This does not simplify NANDs. We don't have anything we can cancel out in this NAND circuit, unfortunately. But it won't do those simplifications. There will still be cancellations to make in NAND circuits, if you know what I'm talking about there. All right, this is the logic converter. The only thing, like I was saying, all you need to do is add your outputs and your switches. All right, thanks for watching.